Number 6, consider the family of functions of the form 1 over 1 plus ae to the negative t with a bigger than 0. First one, what is the limit of f of t as t goes to infinity? So here I think we can do this kind of loosey-goosey. As t goes to infinity, e to the negative t is like e to the minus infinity, which is really close to 0. So that means that this piece right here is a times 0, which is 0, which means the whole thing is 1 over 1 plus 0, which is just 1. So this limit is equal to 1. Part B, find f prime of t and f double prime of t. Okay, so this one is going to get a little bit messy. So to find f prime of t, you could do the quotient rule. So we'll do that. Let's see, 1 plus ae to the negative t gets squared. So we do bottom times the derivative of the top, but the derivative of the top is nothing. So I'm going to omit that term, minus the top times the derivative of the bottom. And the derivative of the bottom is negative ae to the minus t. So those two negatives cancel, and we just get plus that. Okay, and then next derivative, f double prime of t equals, okay, so we could do quotient rule again. Square the bottom. So now we do bottom times the derivative of the top. So the derivative of the top is a negative ae to the minus t minus the top times the derivative of the bottom. This is going to be a chain rule here. 2 comes down, copy the stuff, subtract 1 from the power, then times the derivative of the stuff in the parentheses here. And the derivative of that stuff is, again, negative ae to the minus t. All right, this answer would be fine. It is fine for part B. But given that that later on here it asks us to find inflection points, it seems like it's in our best interest to simplify that derivative. So let's go ahead and do that. Okay, so I guess we can factor some stuff out. What can we factor out here? I can take out a 1 plus ae to the negative t, because that's in both. And I can also take out an ae to the minus t, because that's in both. So let's see what we get when we factor those two things out. So from the first one, let's see, so we'll write it all out first. 1 plus ae to the minus t comes out, as does an ae to the minus t. And then big brackets for what's left over. So the first green thing, it was the green thing squared, so we still have one of them. And then the yellow thing is outside, although I guess we do have a negative sign, which I'll squeeze in the front. Minus. That yellow thing is outside. I see a 2. The green thing is outside. And then I see another minus, which is going to make that a plus, ae to the minus t. And then it's divided by this thing to the fourth. And then we'll simplify a little bit more. We can cancel this thing here in the front with one of these, so that becomes cubed. And then we can actually simplify what's in the big square brackets. So we'll do that, and I think that'll be done. So inside of the brackets, I have an ae to the minus t with a negative in front, and a 2ae to the minus t, so that's just 1 ae to the minus t. And then that 1 in the parentheses becomes minus 1. I think that's as good as that's going to get. Like I said, for part B, we didn't need to do that, but it's going to help us later on. Okay, part C, find all critical points. Critical points, remember, are places where the derivative is 0 or undefined. So we have to analyze here a little bit. Let's take a look at the top. The top has an ae to the minus t. Now a was given to be some positive number. So this is not 0. E to anything is never 0. So the top is never 0. Now let's look at the bottom. That a is a positive number. e to anything is also a positive number, so this whole thing is a positive number, and then we add 1. And there's no way it's going to ever equal 0. So the derivative is never 0 on the top or the bottom, which means there are no critical points. So no critical points because f prime of t is never 0 and f prime of t is never undefined. Part D asks us to find inflection points, which are places where the second derivative is 0 or undefined. So remember, this was the second derivative here. So we'll do D here. Okay, same kind of analysis. Taking a look at this thing in the bottom, it's a copy of what we just looked at in the denominator of f prime. We decided it was never 0, so there's no place where the bottom of f double prime is 0. This piece right here, I think we've already agreed, is not ever 0. So the only thing that could be 0 is this thing in here. So that's the simplified equation we need to solve. We can solve this thing for t, looking for critical points. So add 1, divide by a, take the ln, and then finally multiply both sides by 1. This answer is fine. It simplifies to ln of a if you remember some of your properties of logs. And finally, just make sure that ln of a is defined. We need a to be positive for the ln to exist, but remember that a was positive, was one of the givens. So it says here, inflection points. The only inflection point occurs right there when t is equal to ln of a. I guess technically we should have to show that it is an inflection point, meaning that the second derivative actually changes sign on either side of ln of a. I guess I'll leave that to you. It's not very nice to have to try to do that, but anyway, that thing down there is an inflection point. And then finally, part E, what value of a should we pick to have an inflection point at t equals 10? So let's try that. Actually, we'll go here. Okay, so we need t equals 10 to be the inflection point. So I guess, where should we go? We could go maybe to this equation. A e to the minus 10 is supposed to equal, actually we can go even one step back. We want the inflection point, which means we want the second derivative to equal 0, but it's supposed to happen at t equals 10. So this equation is supposed to equal 0. And now we're solving for a. And we get a is equal to e to the 10th, which you can type in if you wanted to know what that big number was.